All right. So welcome to the afternoon. Welcome to our panel, Building the Mobile Internet. I have with me today two distinguished panelists, Carlos da Silva from Orange and Eric Troyer from Equinix. Carlos is the Strategic Marketing Director for International Wholesale Solutions for the Americas at France Telecom Orange. He was formerly Director of Network Provisioning for the North American Transmission Backbone. Eric, you may know, is Director of Global Mobile Data and Peering.
It's a mouthful.
It's a long title, but with good reason, right? Because Eric is responsible for the overall strategy on both sides of the house, if you will, interconnecting both traditional internet and mobile data. So you might say, well, why is that different?
You might want to turn on the slideshow.
Turn on the, oh, I'm sorry. I did this last time too, didn't I? Here, what's the, You? Not working. Here. Even better. No? All right. Close enough, right? So, as I say, why isn't the mobile internet just the internet? I always thought it was. Part of the reason I wanted to do this panel is because this is an area that was interesting for me. Why is there such a gap between the mobile internet as it's being realized and the traditional internet that most of you represent? So as you know, there's a pretty large historical gap in the culture between voice guys and data guys. You're one or the other. There's not a lot of crossover. And it's been going on, I guess, as long as I've been alive. The funny thing is that finally fixed and mobile voice are converging on an all IP model at long last. The strange thing is that it may not be the same all IP model that you would natively expect as a NANOG participant. These guys have vastly different assumptions at the core about security, about the importance of quality of service, about whether or not you can run an open network or whether it needs to be a second tier of internet, the role of intelligence in the network as opposed to having a dumb network in the core. So it's a little bit of a foreign mindset, I would argue, for people at NANOG. So think of this, as you will, as a cultural exchange moment. This is a little bit of a foreign mindset, but I think that if operators here want to learn to interoperate with the mobile operators and this large ecology of service providers that have been built up around the mobile industry, we have to learn some of these things. So today's panel is a travelogue, if you will. Your tour guides today on Safari are Eric and Carlos. Eric is going to start by giving us a little overview, technically, of how we got to this point, GRX and IPX, and a little bit about the economics and the engineering concerns that drive the mobile operators. So I'll start with Eric.
Great, thanks.
Sure.
Next slide. So not long ago, the executive team at Equinix asked me why mobility is important. And I get really tired of seeing those happy marketing slides of all the stuff that goes up and to the right and the forecasts. So for me, litigious activity really indicates when something's important. So there's a lot of lawsuits going on right now within the handset space in particular. So to me, I thought this was an interesting indication. Next slide, please. So there's a reason why the mobile networks are architected the way they are now. The previous presentation earlier in their day, talking about some of the technical aspects of the radio network, the various protocols and stacks involved with creating that interoperability, was a great view technology-wise on why things are a little bit kludged, understatement of the year, within mobile networks. What I'm going to cover here particularly are a few of the commercial aspects behind the build-out of MNOs and some of the organizational aspects. You know, for good or for worse, there's a reason things are designed the way that they are. A lot of the mobile network operators have a large number of regional operating companies that act disparately from one another. There are few organizations within the corporation that are actually managing those different opcos and how capacity works between them. While there is kind of a master routing scheme involved there, the actual capacity planning and long-term interoperability is a very difficult thing for them to manage on a micro basis. A lot of vendor proprietary services that had been referenced in the previous presentation before, what that has done, interestingly, is it's made a very big market for interoperability providers. A lot of guys in the systems enabler space, people like Cineverse as an example, do a lot of business on the very fact that these networks are architected in a way that requires that interoperability piece to actually work well together. There's a huge prioritization happening right now in the radio and spectrum space. Most of the money within the MNO environment is being thrown at bandwidth at the very edge of the network. That edge of the network is defined by available spectrum and the amount of transceivers and capacity you have out to those towers. That's where a lot of money is being spent currently, less so within the core space and the overall architecture for actually passing those bits back to the global internet as we know it. There's a large concern of commoditization. You know, that's a concern everyone shares across the data services environment. In particular, for the mobile guys, there is a prioritization of average revenue per user. There are a lot of different schemes and mechanisms in place now, packages and solutions that the operators offer to a user to get data services. Things like a social networking package on your phone where you have a common user interface that aggregates all these different social networking tools together to allow you to quickly get between site and share information. Maybe there's a little cloud storage involved with it. Maybe there's some other little super secret sauce that goes with it to differentiate. But the point there is that the mobile network operators are trying to avoid commoditization as much as possible. And an example of that is, historically, things like SMS, messaging and texting. If you look at the graphs on the bottom right, these two graphs were taken from a recent FCC study. So this is taking a look at the US operators and where their revenue contribution came from. The red circle is circled around messaging services. You can see over time that purple swath has been continuing to grow at the same time as IP data services. Yellow indicates IP data revenue. And so while things are moving to an IP-based network and messaging system, you're still seeing tremendous growth happening in legacy messaging protocols. And if that's a high margin product for a network operator, they're going to continue to throw money at the systems that support that. The systems that support that are not the same systems that support a nice flat IP architecture. So again, a business decision on their part on where to put money investment. And in addition, you see kind of the MMS growth traffic over time on the bottom right. Next slide. Another place where money's being spent dramatically is on mobile backhaul. There's a lot of capacity that's being purchased by various mobile backhaul providers. As an example, I've listed Time Warner Cable here in the States as well as Comcast, but Time Warner Cable recently mentioned that it's their largest growing data services product. And it's an indication that the network operators are throwing money into capacity to get to markets and locations where they're running into bottlenecks, but it doesn't necessarily mean that that bandwidth is being used efficiently. Next slide. So I wanted to set this up, this conversation. I had mentioned before that the executive team asked me, why is mobile important? The truth is, Equinix originally became a little bit more aware about mobile about 6 years ago, in 2005. We were approached by the GSMA to run what is called a GRX, a GPRS roaming exchange. The original GRX actually started in Amsterdam. The AM6 is actually running the first ever GRX layer 2 platform, which was designed by the GSMA as an organization to figure out how these operators can interoperate and actually allow data traffic to roam. So when you've got a user who's roaming into a non-home network, how is that traffic going to traverse the various networks? And more importantly for the operators, how is that going to be billed? And any of you guys who are on this conference circuit know what those roaming charges look like. They're significant. It's a significant source of revenue for them. So measuring that data is very important. And the reason we're talking about the GRX is mobile architecture is evolving from this seed of GRX. So it's important to understand the context and the history from where this came from. And so when the GSMA, as a mobile organization who is working on standards, approached this concept, they really wanted to try and closely mirror internet architecture at the time. The concept of an exchange point with a layer 2 switch where a number of participants can engage in multilateral relationships. And so for the GRX, it's important to understand. There's often a misconception that every mobile network operator is its own GRX operator. The truth is there's over 600 mobile network operators on the globe right now. There's about 35 GRX operators. You can think of a GRX operator as being a lot like a transit service provider in the traditional IP world. This is someone who's aggregating together a number of mobile network operators and allowing the interoperability of a roaming session for data to happen between these different providers. And I'll show you a diagram that will explain that a little bit better in the next slide. Actually, let's back up. Sorry. We'll get to that in a moment. In addition to having this layer component, this IX layer component, there are directory services which are essentially kept separate from global internet DNS. So there are third-party directory services that allow for routing information to be exchanged. One of the more interesting and perhaps notorious features of the GRX is that at the time this was deployed, the business support systems for the mobile network operators were very limited. And in order to account for the traffic that was going across these GRX networks so that they could bill the roaming user, it required drastic hairpinning of traffic between the home network and the roaming network to the content source and back again. And I have another slide which I'll show you shortly, which is going to go through that flow. Over time, this just started as a global roaming solution. In addition to that, what they've done is they've added additional services over time, things like UMTS and MMS interworking. And ultimately, as a transition point, as we're talking about the evolution of architecture, the GRX working group at the GSMA, the guys who started this architecture primarily for roaming, have been tasked for the next generation solutions on how they're going to interconnect IP-based applications. And I put IP applications in quotes here surreptitiously because it's an indication of how an MNO thinks about IP. Right now, the thinking is very application focused. It doesn't, an MNO doesn't think of things entirely as flat IP network. It looks at each one of these individual service layers and generally has to do some type of guarantee of delivery of each one of those service layers. And we'll get into that a little bit more. Next slide. So this is the basic GRX architecture. I stole this diagram. You should be happy I didn't draw this because it would be illegible. What you see in the core there, the larger cloud, is really kind of the IX component of the GRX, incorporating the interconnection of a number of GRX backbones. So you'll note the second largest clouds in the middle of that larger cloud are GRX backbones. Those are essentially the GRX operators I mentioned before, about 35 in the world, transit type service operators. They're connecting all these other GPRS operators, who in this instance are mobile network operators, together, and then you can see the logical instance of the DNS for the GRX service is being propagated by that third-party provider, routing information exchanged. Next slide. So this is supposed to be a build slide, so it's going to be a little difficult to talk through this, but bear with me. So if we look at an example of a U.S. subscriber on a U.S. network who is roaming in the UK, let's say that user is trying to access content in the UK. What's going to happen is a very interesting phenomena. The operator in the UK is going to send that traffic to a GRX operator. The GRX operator is then going to send that traffic over to the GRX exchange sitting in Amsterdam. That GRX operator is either going to handle that traffic on their own if they have a roaming agreement with the home network, which is based in the US, or more likely, they're going to hand that traffic to yet another GRX operator who has a contract with the home network in the US. That traffic will go back to an IP gateway, basically a GI for the MNO back in the States. That's where the mobile network operator will make a request for that content. That content is sitting in the UK. They will then go over an IP cloud to get that content. The content will then be sent back to that gateway, which in turn will be sent back to a GRX operator, which will be sent back to Amsterdam, which inevitably will find its way in the UK. Not a very efficient architecture. It was all done for the sake of being able to actually measure the traffic that a roaming user is sending, because the margins are that high. So that's a basic primer on GRX. We bring that up because IPX, people may have heard of IPX, rumors of it, hints of it. There's certainly a lot of marketing that's going on these days in the mobile space around IPX services. IPX is based on GRX architecture. So that group that I had mentioned before, the GSMA, has been tasked with how do we do a next generation solution for connecting this stuff together, because quality of service is important on a voice network, not only to distinguish voice, but other types of data applications. So it's basically GRX with a lot more intelligence behind it is what they plan on implementing. Historically, the GRX has been a closed system. Only GRX operators can attach to the GRX. In this instance, the GSMA and the group involved in this is actually looking at letting non-mobile network operators and GRX operators attach to this system, meaning applications and content and potentially terrestrial type providers. Changes in the way that the mobile network systems are built for their BSS are far more advanced now, so they're looking at ways of doing local handoff of traffic in market. It's a KPI-focused solution where they have defined very rough KPIs. Things like one-way delay, round-trip delay, jitter, packet loss, very basic rudimentary measurements that have been put forth as a standard to shoot for. However, at this point, within the GSMA itself, there's still a lot of dialogue about how that's going to be measured, and more specifically, what attributes do you measure within that service layer. And what I included on the bottom of the slide is kind of a basic overview from GSMA literature that shows all the different features they want to enable in IPX. And it's important to see it really does look like a huge wish list for creating a QoS type network. As I mentioned before, there's a lot of marketing happening at IPX right now within operators. A number of what you're hearing right now, so you can almost bifurcate this conversation into two realms. One is there's the GSMA IPX, which is a standard that's being proposed whereby mobile networks can interoperate with one another and open up their connectivity with QoS to other providers. Another form of IPX that's being discussed now is an actual service that's being provided by people like mobile networks and systems enablers, which is basically transport around the globe with QoS enabled on it that allows for different types of services, things like VoIP, voice VoIP, SS7 over IP, MMS, to be QoS tagged and ensure their delivery pipe to pipe. Next slide. So one of the things that I have to ask as a question, someone who spent time building internet backbones and peering, is can something like IPX, as complicated as it sounds and as un-internet as it sounds, can it help the mobile networks start to deploy something that looks more like the internet, something that could get us closer to the edge of where internet traffic is being exchanged now? And in places like the US, as an example, there's a large mobile network operator that has 4 primary GI points where there's gatewaying of traffic. And sessions in places like Silicon Valley have to go all the way up to Seattle and back down again multiple times for sessions. A less extreme example of what you saw for GRX. Next slide. And so there's evidence of this happening. If you look at Akamai's State of the Internet report from last year, they noted that in New Jersey there is a tremendous growth in the per capita IP usage there, and that's primarily driven by proxy and gatewaying of mobile network operators. And so just, a few thoughts on IPX's impact. There is potential that IPX can drive traditional peering. If IPX is extended to locations where peering's happening now, it is quite likely that you're going to see more direct interconnection happening. Obviously, over time, as things scale, there will need to be more distributed architecture to allow for the mobile networks to scale. The architecture itself is likely to be composed of a combination of closed networks and IP-based internet networks, kind of like what we're seeing now, but perhaps potentially more formalized down the road. IPX, in a lot of cases, will look like transport. It's going to look like a transport mechanism that will allow the various mobile networks, there's over 600 of them, but the ones that cannot afford to deploy globally to points where they can actually meet other providers, IPX will probably be a way for those guys to obtain services in other regions. And beyond that, I think now more than ever is really a good time for the GSMA IREG group that's responsible for GRX and IPX evolution to start talking with IP operations forums like NANOG. It's going to be important in order for us to be able to facilitate that inter-exchange between what is the traditional internet today and what the mobile networks look like today.
Very good. Just one question before we move on. I think we chatted about this a little bit before. Would you say that that those working groups are closer in spirit to something like the IETF, or are they closer in spirit to NANOG? And which should it be? Loaded question.
Yeah, well, they look a lot more like the IETF, and that's not necessarily a bad thing. But what is missing is a certain spirit of cooperation between companies in some cases. So, there's the engineer archetype that sees a problem and their eyes light up and they see a potential solution and they want to hash through that in a meeting. That happens at the IREG meetings. But what happens as well is every person in this room is a competitor. They're competing in overlapping markets, and that little corporate chip that's installed in their head that says we have to be very careful about how we discuss things in a room with competitors goes off. And that's one of the reasons that things kind of take a while to evolve over time.
Okay. All right. Carlos has a little something to tell us about the differences between voice and non-voice.
Yeah, so it's more than differences is a message that from a mobile operator, what we bring to and a carrier, what we bring to the GSMA, and a reminder for all the IP guys that there are some considerations that are not just taken from the perfect and the most efficient IP world, but from a business world. So Eric was saying earlier that data is very important. It needs to be built accurately. Indeed, all of you that are roaming here from abroad today, you'll probably generate a lot of data roaming revenue to AT&Ts, mostly T-Mobile, etc. But you will generate much more voice revenue. So voice is still at the heart of where the revenue comes from. It will be for the coming years, and therefore, even in IP network, the impacts of voice will be critical. So, well, I'll pass that on because Eric did quite a good job of explaining that. The IPX principle, so you have two service providers, and the idea of IPX is that there are different providers the same way that there's different internet providers today. And most of the services that we'll go through are voice, of course, through GRX, which is the GPRS service, but it's also used to carry SS7, RCS video conference, SMS, etc. Old school, what I call old school services, but that are very important for the revenue stream of all the mobile operators. So they want to be careful that the transition from GRX to what is IPX will retain all the specificities they had before and would not impact the revenue. The IPX feature is, and that's a lot of marketing spin on it, but the IPX feature, why do we need to go from an IP to an IPX from the GRX today? A lot of it is talking about QoS. The QoS will be better because there will be enablement of classes of service. and packets will be tagged differently, whether it's voice, video conference call, or SMS, and basically more or less time sensitive. It's also a strong change on the fact that GRX today doesn't really have a QoS cascading and doesn't have billing cascading, so it's not possible to charge for a receiving party and cascade back the same way that the voice business works today. So all that will enable this transition, not from GRX to IPX only, but from the TDM world of voice to IP, and that's even more important. It's how do we go from TDM to IP, and in the process go from GRX to IPX. Next slide. So a bit of how things work today between what I put customer, but here it's a mobile operator mostly. It could be another, not just a mobile operator in the IPX world. So you have voice over IP access. So that's a dedicated trunk that goes directly, for the case of Orange, to our IP AS, and then you get like other services that are specific to the mobile community. So 3GRX, that's the IP traffic. Sigtron is a signaling traffic for SMS. Then you have BlackBerry that has its own network that's secured and well defined between everybody else through VPNs. So all that goes through what is called the GRX, which today is for Orange's AS2300. And then at the bottom line, you have the biggest chunk of traffic, which is natural voice traffic. That's TDM traffic. Next slide. So what's the idea of IPX? The idea is that all these services collide in the same access. So again, here nothing new. It's just talking about convergence, and it's not so much convergence of service. It's convergence of networks. Try to decrease the unit cost by using the same IP pipe access and the same IP network to transport all these services. Next slide. But before we get into that and just talking about specifics, so how does voice, what's the role of voice? Voice will be the major service over IPX as first. I'm talking about revenue-wise. Okay, it's not the sexiest one for sure, but it will be the biggest one, and as such, it will be the one with a very important specification. Voice is not just an application over IP. And that's been a lot of spin from the IREC folks taking GRX to IPX and saying that voice will just be another app, the same thing than video conference, and whatever else. Well, the fact of the matter is that voice is not just an application over IP. I'll come to that after. QoS cascading for voice is much more important than IP transport for QoS. And I'll explain that again after. And consequently, voice will bend some of the IP rules that you are all familiar with. Next slide. Today, the voice path is driven by business rules, and in a different way than in the IP world, carriers do not always look for the shortest path. It's not what prevails. What prevails is what's the shortest, cheapest path, and with a lot of commitments, it's much more complex than peering or transit. It gets way more complex. It's been like that for years. There's a huge industry involved in that. So. In the IP world, there's this notion that it's always the direct path. In the voice world, it doesn't have to be like that, and as a matter of fact, it cannot be like that. So no hot potato routing in the current voice model, and moving to voice over IP means that there will be no hot potato routing for the voice sessions either. More than 95% of the international voice today still originates or terminates in TDM, which means that if someone decides to go to an IPX for its voice, it means that this IPX needs to be connected to the internet or to the TDM network, because if you want to make a phone call to somebody, there is 95% chances that that somebody will not be in an IP network or will not be in an IPX network. Yep.
Mike.
Oh, there's a question. If you can open the mic.
Dave Meyer. This is interesting. I'm getting this sense of deja vu here about this QoS stuff. I can remember this similar. Well, I understand that that voice is a different animal and it has its requirements and all this stuff. But I can remember these same discussions happening when the IETF and all of these other people were promising QoS on internet scale backbones, and we kind of all know how that worked out. Why do you think this is this qualitatively different in some way, or does it have some kind of different property that will save this scheme from what happened with internet QoS? Well, and let me just clarify. Basically, at the end of the day, too much state, cheaper to get more bandwidth.
The problem with voice is not in the transport. It's what makes a voice call good or bad is very rarely on the transport. What makes a voice call being good or bad is how many carriers do you have to go through, how many times do you go around the planet before you reach the person you're calling. If we call from here in Miami, and if I call Europe, am I going to go straight over the Atlantic to Europe, or am I going to go across Asia, or am I going to go to Asia and then come back to the US and then go to Europe? In an IP world, most likely I'll go straight to Europe. Well, in the voice world, most likely I'll go straight not to Europe. And the reason is if what happens in voice is that I will look at which routes I get. To make it short, because it can be a bit complicated, voice is a bit like the airline industry. The shortest path, the direct path, is always the cheapest. Is always the most expensive one. Always. If you want a cheaper flight, chances are that if you increase the number of ops you do, you'll get a cheaper flight. It's the way voice works. So it's not about the quality you get going from one leg to the other, because that chances are that that leg will always be the same. It's how many legs do you have to go from point A to point B. And that's how voice is run today. So the IPX will not change that. I have a diagram just after that will illustrate a bit more about it. But other than transport quality, route quality, there is codec quality, there is signaling quality, there is security quality. All that makes a voice call what a voice call needs to be as far as quality. Okay, next slide. So this is an example. So here you have in the IPX, like in the GRX, you have three main points, inter-exchange points. So Ashburn, Singapore, and Amsterdam. So if we look at, let's say, two operators here that interconnect and two GRX and IPX providers. The first one is the blue line, the second one is the gray line, and they both interconnect in Ashburn. And if you're in Canada and over the GRX you ping a destination in Argentina, that's the blue plus the gray is the path that the IP packet is going to take. So you're going to get a direct path and it's going to be great. Now let's say that over that IP path you want to place a voice call. The voice call is going to actually go from Canada to where the switch equipment, the voice switch equipment is. And the switch equipment might very well be in the Middle East. And a Middle East operator might be very well selling in Canada destinations, calls, minutes to call Argentina at a cheaper price than a US operator. So depending on what you buy when you're in Canada, either you buy these calling cards that are inexpensive, either you buy from Rogers, either you buy from somebody else, the call will go either to the direct route, either to the cheapest route. The cheapest route here will be over the IPX. It will be the red path. So it will go to Ashburn, then jump into an IPX provider that will go to Europe, to the Amsterdam, then go to the Middle East operator and come back to Ashburn and then go to Argentina. So what we see here is that the voice pass has a completely different route than the IP pass. Voice is session-based and not packet-based like we see in BGP and all that kind of stuff in IP. Right. All right, so that makes a big difference. Next slide. Limitations on voice and impacts on the IPX based on voice. So IPX cannot be an island, and again that's because most of the voice phones today are not based in IP. So if you want to place a call in IPX, you need to make sure that this IPX is interconnected to other networks, either internet, either TDM. As today, the GRX is not directly connected to the internet. The IP sessions are broken by voice equipments. So if you look at the pass, the red pass that I showed earlier, that voice switch breaks the session. So all the information about round-trip delay, for instance, you don't get them. You get round-trip delay from Canada to Middle East, and then you might get another round-trip delay from Middle East to Argentina, but you don't get any information about the round-trip delay for the voice call from Canada to Argentina, which makes all the QoS parameters inefficient because you're measuring something that you don't know which path it took. Voice calls are routed to voice destinations, not to networks. So when we call, when we make a phone call, you call a network. You call AT&T. You don't call a country. you call a voice network, you don't call an IP network. There is no such thing as IP address. It's a phone number, and you need to reach the network that hosts this phone. If it's in roaming, you need to manage number portability and all that kind of stuff. That makes IPX, the routing in IPX for voice, much different than it could be if it was just IP. And also in voice, the voice regulation imposed that a lot of restrictions that are specific to voice. You cannot filter and have blacklist, whitelist as we have in the GRX and might have in IP. The international regulation for voice forces you to receive all the calls that get to you. You cannot block calls because you don't like this originating country, or you don't like this originating network, or you don't think it's safe, unsafe, etc. If a call is coming to you, you need to accept it. So those are just a few sets of specificities of voice that will influence the IP world. So, conclusion. IPX is very promising because it brings quality in a world where today there isn't any. And again, it doesn't mean that the quality is bad. It means that the quality is not measured and not committed upon. Voice will be a cornerstone on the IPX business. So even though it's just one of the many services, it's the service with the most revenue, and it will have its own specificities. It's not just another app. And ultimately, Orange, among many other operators through the i3 Forum, which is an association of carriers, is working with the GSMA to try to come up with pragmatic approaches on how to put this voice over IP and make sure that IPX is also something that's compatible and takes up quickly. That's it.
Very good.
I just wanted to make a quick comment to Dave's question. This is just me being an unbiased reporter based on what I've observed. With IPX, the way that the GSMA and the IREG is looking at IPX, QoS is a big focus for them, no doubt about it. The other big focus for them seems to be KPIs, key performance indicators. What they want to be able to do is end-to-end through the entire data path, measure a number of different indicators for how things are working, and they want to be able to build SLAs on them and everything else. So that's one of the other key things that's pushing IPX. Now, with respect to QoS itself and the throwing bandwidth at the problem issue, definitely I've heard conversations at IREG meetings where there is a huge concern on their part that voice gets squashed when things get busy in the network. And there's a huge amount of data being thrown around in certain portions of a mobile network, a la the backhaul stuff, but that's only one working division of the network. At the other points of where signaling's happening and the voice handoff, that's an entirely different group, and they're not capacity planning in the same way. So I think one of the key things there is there needs to be better coordination within the mobile network operator to that respect. And then my other point before, the last point that I made is it is important that the mobile guys get into the IP operations group so they can learn that lesson like you had mentioned before, because there's history there that's been learned by a certain group, and that's applicable to what's going on today.
Very good. We have time for maybe just a couple of questions. Nobody? Yes.
Question for Eric in terms of capacity planning that you just mentioned. I noticed that over the last few months, a number of European carriers and at least one US carrier have started to identify what they call large users of data, and they started charging these people extra money for the number of bits that they download. I just wondered, what's your view? Is this a method of bringing in equity and charging high users a little bit more money to make it fair, or is it more a case of the fact that most of the operators very, very badly misjudged just how popular what the demand would be, and therefore this is a method of throttling back the usage by the big users?
Well, as someone who worked at an MSO before here in the States, we had that same issue, and the primary driver behind it was capacity more than anything else, less equity, just due to the fact of the service model and what was being billed, because it was a multi-service operator. There was money coming in for a lot of different services, and so it ended up being more of a capacity issue. in my viewpoint, from what I've seen so far, I think that echoes that.
Very good. I think our time is almost at an end. I hope you've seen that there's a lot of people here with through the looking glass expressions on their faces. It is, I think, as I said, a cultural issue. I think it's like, as if you've been presented with the logic of like non-Euclidean geometry for the first time. You say, there is logic here, it's internally consistent, it's not the one I know. I think it's interesting. I hope we get to talk more with this industry at NANOG over time. Any other questions? All right, let's thank the panelists.